Okay, our speaker tonight is Dr. Hugh Ross, president and founder of Reasons to Believe. Dr. Ross was born and educated in Canada. He earned his PhD in astronomy from the University of Toronto. He did his postdoc at Caltech. He's the author of many books, including More Than a Theory, Why the Universe is the Way It Is, Creator in the Cosmos, and Weathering Climate Change.
Very good. I'm going to talk about trees, which is a little bit outside my discipline, but I'm going to try to put a physics and a geophysics perspective on it. So here goes. This first slide is just simply to let you know that Reasons to Believe does have a 24/7 YouTube channel. It's free to subscribe. And when you subscribe, it'll alert you to all the videos and the categories that you want to be alerted to. And RTB_official is your gateway to all the social media sites that you can see at Reasons to Believe. And every one of the staff scholars at Reasons to Believe has a Facebook and a Twitter page where we take questions. So if you're like me, you think of your best question 3 hours after the event is over, and that happens, you can always post your question on my Facebook and Twitter page. And hey, if you got skeptical friends, you can encourage them to do the same. I'm going to begin with something you may be aware of, but astronomers have just discovered, how's this going to work? There we go. This is the largest galactic structure ever discovered. And the galaxy responsible for these gigantic radial lobes is that little tiny dot in the center. You can see a couple of small jets emanating out of that dot. That little tiny dot is actually quite a bit bigger than our entire galaxy. And it's throwing out these powerful jets from a supermassive black hole. And at the end of the jets, you get these gigantic lobes. And to give you an idea of the scale we're talking about here, it's about 16.3 million light years across. But here I show a map, and this is to scale, of our local group of galaxies. There's about 200 galaxies in the local group, but only 7 of them are big enough to actually see on a map like this. And you know, we got 2 large galaxies, the Milky Way galaxy, the Andromeda galaxy, and then you got 5 relatively large dwarf galaxies and about 150 smaller dwarf galaxies. But the entire local group is actually smaller than this single galaxy. So this next slide shows you the size of this galaxy, where those 2 purple stars you see there represent the distance between the Andromeda galaxy and the Milky Way galaxy, which is approximately the cross-section of the local group of galaxies. And this is, I'm going to actually writing a blog on this. It'll be out in a few weeks, but making the point that what we're seeing here are these radial lobes expanding into the intergalactic medium, and the density of these lobes is barely greater than the intergalactic medium. And so astronomers are now realizing if we do a deep survey for these kinds of radio galaxies, what we call giant radio galaxies, it's going to be a powerful probe of the intergalactic medium properties, which is one remaining test yet to be done for the Big Bang creation model. In fact, it's going to enable us to determine which one of the several, what we call lambda CDM Big Bang models, is the correct description for the universe. We know enough about the Big Bang to realize that dark energy is the dominant component of the universe, and cold dark matter is the second most dominant. But we have yet to identify the specific properties of the cold dark matter and the dark energy. And if we were to get, say, 100 of these kinds of objects, this is the first one discovered. There's only one telescope in the world that's capable of discovering these. And the team that made this discovery went through the very latest database and kind of took out all the bright sources so they could see the faint sources. And this is what they discovered. But a deeper survey potentially could reveal 50 or 100 of these objects. And the bottom line is we'd wind up with a more detailed lambda CDM Big Bang creation model. And the bottom line is it would make for a stronger case for the Bible's cosmic model, namely that we live in a universe with a space-time beginning that continuously expands from that beginning under laws of physics that don't change, or one of those laws is a pervasive law of decay. But with that, let me jump into the trees. And I'm going to jump into the trees literally. And this particular slide shows you a forest of aspens. But the interesting thing about this particular forest, I took this photo in Colorado, is that this is actually a single tree. And so when people ask me, well, what's the largest tree on Earth? It's not the giant sequoias in California. It's actually these aspen colonies. So a single tree will send out all these roots that give rise to other trees. So this is actually a single plant that you're looking at. Now, literally hundreds, if not thousands, of trees that all come from one seedling. But the question I want to address this evening is, what if trees did not exist? And it's based on a research paper that got published a few weeks ago, making the point, actually a few months ago now, got published in Nature, basically revealing some of the things that trees do that we did not realize before, and how there'd be no possibility for human beings or civilization if it wasn't for trees being the dominant plant species on the planet. You not only need trees, you need a whole bunch of trees in order for human existence in our civilization to be possible. And of course, the simple answer would be, if trees did not exist, there wouldn't be much shade unless we had these human structures. So trees provide shade. I think we all realize that's a critical factor for many plant and animal species to be shielded from, at least to some degree, from the light and the heat of the sun. But there'd be far worse consequences. There'd be no biological penetration of bedrock. And that's what this paper is all about, is that one of the unique features of trees is they have the capability of penetrating bedrock and penetrating it to about 20 feet or more below the surface. So in this particular slide, this is one in British Columbia, where you get to see a bedrock cliff face. But notice there's trees growing all along the top of this bedrock. And the reason they're able to survive is that the roots are able to penetrate 6-7 meters into the bedrock and drop all the water and nutrients they need to thrive. And it actually has the capability of transforming the bedrock. We'll get into that later. But just in terms of bedrock, we live on the North American continent, and it's the bedrock champion of planet Earth. It's got more surface bedrock than any other continental landmass. And so here we see North America. And for over half of the unfrozen part of North America, bedrock is less than 1.5 meters below the surface. So you might have a little bit of soil on top of the bedrock, but as soon as you go down about 4.5 or 5 feet, you've got bedrock. Now, of course, if you're talking about the front yard and backyard that Kathy and I own here in Southern California, and both the front and backyard, the bedrock is less than 5 centimeters, which explains why we have such great difficulty trying to grow a lawn or anything else for that matter. And, I was, as you heard in the introduction, born, raised, and educated in Canada. Most of Canada is bare bedrock. In fact, you've got what's called the Canadian Shield, and this shows the extent of the Canadian Shield. It actually covers an area that's bigger than all of Australia, and most of it receives very little precipitation. The rainfall or precipitation upon the Canadian Shield, by the way, a good chunk of the Canadian Shield extends into the northeastern and central states of the United States. it receives less than 10 inches of precipitation per year, and yet most of the Canadian Shield is covered with forests. And this is a photo of the Canadian Shield, and you can see, you can walk around it, it's basically bare bedrock. Nevertheless, you got trees growing everywhere. And so no soil, just bedrock, and yet trees are able to thrive upon this barren bedrock in the Canadian Shield. It's barren of everything except these coniferous trees. And this is a photo I took in Yosemite Park of a cathedral peak. And here it shows that trees are able to grow not only on bedrock, they can grow in very steep bedrock. So even when you've got a slope of 60 to 70 degrees, you can still find these conifers growing there. And maybe you've tried to climb anything that's steep, you're grateful for the few conifers you can grab a hold of. The root system gives you a secure hand and foothold as you try to go up one of these peaks. And the only thing that can grow on these solid granite monoliths are trees and tree-like shrubs that possess the root system that can penetrate to bedrock. And I think the record here on Cathedral Peak is they found roots going down as much as 30 feet into the bedrock. And what trees and woody shrubs do is they tap into water and minerals residing in bedrock pores, fractures, and they're able to draw up hydrated minerals. And you literally can find trees in bedrock growing out right out of the rock. Here's a photo I took in British Columbia where you got a slab of rock and you got a tree growing right out of the top of the rock. And it's because the seed came in there and the roots went down and were able to penetrate the tiny pores and cracks in this slab of granite. And you actually get a full grown tree growing out of this slab of granite. And trees fulfill the role that they enhance the storage of water and minerals in the bedrock. They do that because as their roots go down into the tiny cracks, the roots grow, and the roots are designed in such a way that they're actually stronger than the bedrock. So as the root begins to go down into a tiny fracture, it begins to expand, and it can actually push open a larger pore, which allows more rainfall and snow melt to go down into the bedrock. And so the roots have this, I mean, it's incredible. They're actually able to go into the rock, and then the roots can expand and break open. They can create new cracks. They can widen the pores and basically wind up breaking up the bedrock and eventually allowing other plants to thrive, because as they continue to break up the bedrock and penetrate deeper and deeper and broader, this gives the capability, actually forms a little bit of soil and allows other plants to join them in thriving on the bedrock. Well, what this paper published in Nature does is it's the first time that geologists had actually determined the amount of water that's stored in North America's bedrock root zone. And they defined that as the upper 20 feet of a bedrock. So they did a survey, and it was predominantly done in Texas and California, but they did it also in several other states and came up with a fairly accurate estimate of the total quantity of water that's stored in the upper 20 feet of all the bedrock in North America. And what they discovered is that trees and shrubs lose 95 to 99% of the water they access through transpiration. So here you got these trees and big woody shrubs existing on bedrock. The roots penetrate. They draw up the water that is seeped into the bedrock, tiny bits of water there, and then it goes into the tree, and the tree transpires 95 to 99% of the water that draws up out of the bedrock into the atmosphere. And it's the transpiration of the water in the atmosphere that actually creates more rainfall that falls all over North America. So for example, the Canadian Shield area would have nowhere near 10 inches of precipitation per year if it wasn't for all the trees that are growing in the bedrock. The transpiration of water by those trees into the atmosphere actually is responsible for almost all of that rain and snowfall over the Canadian Shield. And so by measuring the transpiration rates, geologists determined that trees in California and Texas access almost all their water from bedrock. Yes, they get a little bit from the surface water that falls as rain, but literally over 90% of all the water that trees draw out in California and Texas come from the bedrock, and typically from the deep bedrock. And the geologists determined that water from bedrock accounts for over half of California's above ground carbon stock. And so what they're talking about there is all the plant tissue that exists over the entire state of California, and recognizing that water drawn from the bedrock accounts for about 55% of all the plant tissue that exists in California. So California would look quite barren if it wasn't for all these trees and shrubs drawing up water from the bedrock below. They also showed that for California, the volume of bedrock water transpiration exceeds all the water stored in California's reservoirs. And I think all of you have been around California enough to realize California stores huge quantities of water in the reservoirs. There's dams everywhere over California storing up rainfall and the snow melt. But the volume of bedrock water far exceeds all the water that California stores in its bedrocks. And the California reservoir storage is 16 million acre feet. So we're in a drought right now, but the average for the past 20 years of California's water that it stores in reservoirs, 16 million acre feet. And what we see coming up out of the bedrock, the volume of water that's drawn from the bedrock and transpired to the atmosphere. So it's just the water that gets into the atmosphere thanks to trees transpiring the water they pull up out of the bedrock. That's in excess of 22 million acre feet. So it's actually quite a bit greater than all the water that's being stored there. And again, we wouldn't have the volume of plants and trees in California if it wasn't for trees having that capability. Okay, what have we got here? Here we go. So the bedrock water that's transpired by trees into the atmosphere, at least in Texas and California, it's more than doubles the precipitation that falls in those two states. So take whatever the precipitation is in your area and realize if it wasn't for trees, it'd be less than half of that. It's the critical contributor to the carbon cycle. We'll get into that in a minute. It's a critical contributor to the deep water cycle. I've written a blog on that you can catch at reasons.org. How, yes, there's a water cycle in the atmosphere, but there's actually a deep water cycle that sends water from the crust into the mantle and then back up to the crust. And actually, this is responsible for generating more oxygen in the atmosphere than we actually get from photosynthetic plants. And thanks to this bedrock water transpiration, worldwide, not just California and Texas, but worldwide, this more than doubles the total biomass of planet Earth. So all the plants and animals, over half of that is directly there thanks to water being transpired from the bedrock by trees. And it yields easy to exploit huge biodeposits. We'll get into that in a minute. And lastly, it compensates for the sun's increasing luminosity. And let me just show you this. Here we go. So this graph here basically shows you the brightening of the sun over its history. When the sun is forming, it's accumulating mass, and the brightness of a star goes up with almost the fourth power of its total mass. So when the sun is accumulating matter, its luminosity is rising very quickly, but then it stops accumulating matter and actually begins to lose a little bit of the mass that accumulated. Loses about 5 to 7%. That's enough to drop its luminosity by a factor of 2. So yes, there was a time when the sun was twice as bright as it is now, but it lost 5 to 7% of its mass, and that actually brought it down to about 78% of its present luminosity. And then nuclear fusion began to kick in the core of the sun. And so hydrogen is being fused into helium, and that allows the sun to begin to brighten, because as more and more hydrogen is fused into helium, that causes the solar furnace, nuclear furnace, to burn ever more efficiently. And so in the last 4 billion years of the sun's history, it's been getting brighter and brighter because it stopped losing mass at any significant rate. And meanwhile, nuclear fusion was becoming progressively more efficient. And this graph shows you the era when all you had on planet Earth was microbes, and then the animal era, which would be about the last 575 million years. And so today, the sun is brighter than it's ever been in the history of life on planet Earth. It's about 22 to 24% brighter than it was when God created the first life on planet Earth. And I actually have been giving talks making the point that one way that you can help help theistic evolutionists and atheistic evolutionists recognize that God's divine intervention is necessary, is to help them recognize the sun is not constant. The sun is getting brighter and brighter. And therefore, it's important that you have life on planet Earth that exactly compensates for the brightening of the sun. As I've written in Improbable Planet, life can only tolerate about a 1% change in the brightness of the sun without there being mass extinction events. And hey, if it's 2%, you wind up with the entire planet being completely sterilized of all life. So life cannot tolerate a large change in the solar luminosity unless that luminosity is compensated by life progressively drawing more and more greenhouse gases out of the atmosphere. So for example, we know that at the beginning of microbial life on planet Earth, there was 1,000 times as much carbon dioxide in the atmosphere and close to that many times more methane in the atmosphere. So the early Earth had a much greater abundance of these greenhouse gases, but thanks to the very fine-tuned introduction and removal of just right light at the just right times, the greenhouse effect of our atmosphere has been brought progressively down. So as the sun gets brighter and brighter, our atmosphere traps progressively less and less light, heat, and light from the sun. And the mechanisms that are most responsible for this compensation have changed over the history of the Earth. But the one that's most dominant right now is what's called the carbonate silicate cycle. And this is just to help you remember your high school chemistry class. This is in the case of calcium silicate, but it's basically making the point here that this chemical reaction, falling rain, and snow works as well if the snow melts. So melting snow and falling rain, falling upon exposed silicate land masses, the water acts as a catalyst. And so the reaction is you've got water and carbon dioxide reacting with the different silicates. In this case, we're talking about calcium, but sodium would work the same way, or any other metal you put in there, iron or whatever. This is just an example for calcium. So you got the silicate reacting with the liquid water, the atmospheric carbon dioxide, and it makes carbonate, in this case calcium carbonate, and it releases carbon dioxide and releases the water. Well, you notice that the water is neutral on both sides. The same amount of water that comes into the reaction comes out of the reaction, but that's not the case for carbon dioxide. You get two carbon dioxide molecules coming in, only one comes out. So by this means, carbon dioxide is removed from the atmosphere, and two other benefits you get from this reaction is that you take a relatively useless industrial product, namely the silicate, and you get two very valuable industrial components, sand and carbonates. Sand and carbonate, for example, are the primary ingredients for making concrete. And there's many other uses for that as well. So thanks to this carbonate silicate cycle, we get abundant supplies of two crucial industrial products to sustain our civilization. At the same time, we're drawing carbon dioxide out of the atmosphere. And that compensates for about 80% of the greenhouse gases being pulled out of the atmosphere right now. Plate tectonics burying plant tissue accounts for the other 20%. So if you get a massive flood, or you get a tectonic event or a landslide that winds up burying lots of trees and plants, instead of those trees and plants decaying and releasing carbon dioxide to the atmosphere, they get trapped into the crust of the earth and pulled down into the mantle. Some of that gets returned by volcanoes, but there's a net transfer of that carbon dioxide and methane as well into the crust of the earth. So in answering the question, what if trees did not exist? Number one, human life would be physically impossible. Number two, Earth would have become sterile in relatively short order. And three, we'd have much fewer biodeposits. I would argue that carbonates and sand is the most abundant of those carbonates. Think limestone, marble, sand, that's the most abundant, but you also get a lot of other biodeposits. And it's thanks to bacterial activity and those bacteria being driven into the crust of the earth, those bacteria actually wind up taking the soluble metals of the earth and converting them into insoluble minerals and concentrating them, and we mine them. So a lot of the valuable metal mines we see around the earth, including even uranium, has been concentrated by billions of years of bacterial activity. Number four, Earth would be much less beautiful. I mean, trees are pleasant to all life, but particularly to us humans. And of course, there would be no shade. And so if you want to read more about this, I write about an improbable planet, and I've written two blogs on this bedrock water that you can see at reasons.org. Every Monday morning, I post a blog called Today's New Reason to Believe. And what I try to do in my blog, typically there are about 1,000 words, is to talk about some recent scientific discovery that gives more evidence for the Christian faith and the inspiration and inerrancy of the Bible. Basically trying to publicly demonstrate the principle we see in Job and Psalms, that the more we learn about nature, the more evidence we'll uncover for the supernatural handiwork of God, and the trees is just one of them. Now, I've always lived in a place where there's trees, but I've actually visited places where there aren't trees. Places like Mongolia and Arabia, where you can walk for several hundred miles and not see a single tree. And I can tell you that there's something that happens to the human psyche when you're in a place where there's no trees at all. all you see are plants that are just a few inches above the ground. Some of the offshore islands here in California have that characteristic as well. It actually impacts the human psyche. They've done experiments where they indicate that the more trees that people have around them, the less depressed they feel, the less anxious they feel. And actually, one of the blogs I've written was a study done on school children and done on toddlers. So children younger than years of age of 10, and they found the most dramatic effect was for children between 18 months and 5 years of age. And so they would have these preschools where the children were not being exposed to trees. That was one experiment where they were exposed to trees for only a few minutes when they walked into the classroom, another classroom. And then the other one is where the teachers would take the children out and have them walk or hike through a forest, and then they would disappear and let the children play. I think we all realize children have a lot more fun when they're not supervised by adults. So they did that as well. But they discovered that children that are exposed for more than an hour to a wild forest environment actually perform better in school. They don't have anxiety issues and depression issues. And I hear the studies being repeated on adults. I anticipate that you're going to get the same effect with adults. Anyway, you can check out the book Improbable Planet. And we're hoping that next month, this book will be released, Designed to the Core. And it's a book where I start at the scale of the entire universe, and then I go into the cosmic web, our super galaxy cluster, the galaxy cluster we live in, the local group, our galaxy, and then looking at the local spiral arm that we exist in, the local bubble, the local fluff, our solar system, and the book ends where I go into the interior structure of asteroids, comets, the moon, the sun, and the earth, basically making the point, no matter what size scale you choose to examine the universe, on the largest scales down to the smallest scales, you will find, if you look, overwhelming evidence for God's supernatural design to make possible not just the existence of human beings, but specifically the possibility for billions of humans to be redeemed within a few thousand years from their sin and evil. That's something we're exploring at Reasons to Believe. The books we're writing now, several of the books we're writing, are basically making the point that you get the strongest evidence for supernatural fine-tuned designs when you put it in the context of what's necessary for billions of humans to be redeemed from their sin and evil in a short period of time. And kind of what I introduce and design to the core is when you go through all of Bible texts on creation, it makes the point repeatedly that God begins his works of redemption before he creates anything at all, which would imply, or at least suggest, that everything that God creates is for the purpose of redeeming humans from their sin, in which case we would expect that when we look at the details of the universe at all these different size scales, we'll see that it's been designed to make possible the efficient and rapid redemption of billions of humans from their sin and evil. And I'm hoping that non-Christians, as they read this book, will recognize, and I'm really appealing to non-Christian scientists saying, look, I know you're not a Christian, I know you don't believe in God, but if you will simply do your scientific research from a biblical redemptive perspective, I think it will make you a better scientist. Why don't you try it and see what happens? And I'm trying to do that as a way to get them more seriously thinking about the claims of the Christian faith and the Bible. Well, my clock says I've gone exactly 30 minutes, so I'm going to stop here and I'll take questions. And I'll take questions on any subject. I mean, I think you like to do that in your chapter meetings. So you can ask me questions about the talk I gave. but I'll take questions in any subject. And how about if I count on, you, Kirby, or uh, you, Kirk, if you could just moderate the questions for me. I think that'll make it more informal. If you want me to look at the chat, I can, but.
I don't see anything on the chat actually right now. So I'm going to suggest that people unmute themselves and go ahead and ask their questions.
Hi, this is Ray. I have a question that relates to your comment about the psychological studies on children and so on. What do you think of the idea that elemental forms of life have consciousness, like maybe even plants of some kind? And you hear stories about there are people that if they talk to their plants, they grow better and various things like that. So what do you think about that idea of some elemental sort of consciousness in the very lowest levels of living things?
Sure. Well, I do recommend talking to your plants. They will grow better if you do that. But the reason why they grow better has got nothing to do with the plant's consciousness or desires. It's got everything to do with the fact that when you approach your plant and talk to it, you're breathing carbon dioxide on it. And plants do grow better at a higher level of carbon dioxide. And by the way, a lot of people have been thinking, well, maybe we shouldn't worry about pumping more carbon dioxide in the atmosphere. It's going to make trees grow better. It's going to make the plants grow better. That's true up to a limit of about 600 parts per million. On the other hand, once you get past about 400 parts per million, it does begin to degrade respiration. And we're animals. And by the way, all life respires, including the plants. And so, yes, they grow better, they grow faster, but the respiration will be degraded. So I would recommend that it's not a good idea to allow Earth's carbon dioxide level to get up to 600 parts per million, because you will begin to notice some subtle health deficiencies once you approach that level. So how are we doing right now? 400 or 415, where we're at right now, is not a problem. You don't get to see any noticeable respiration issues until you begin to get north of 500. And when you get to 900, for humans at least, you will see really severe respiration consequences. So, but yeah, that's why plants do better when you talk to them. They're getting more carbon dioxide from you. That's a good idea. Get your friends to talk to your plants too. That'll help them grow a little bit better. In terms of consciousness, I've got about 50 books in my office library written by unbelievers trying to explain consciousness. And you notice they come up with all kinds of different definitions. So for example, a lot of them will think that birds and mammals are conscious because they're able to display emotion, to express and receive emotion. They're able to express a will. They can be trained to do things. And they do seem to have some level of self-awareness. But many experiments demonstrate they do not have theory of mind. I mean, one of the unique features of us human beings, we can talk to one another, look at one another, and get some idea what the friend we're talking to is actually thinking about. And that appears to be unique to human beings. And of course, Christians would define consciousness as the capability of being aware of a divine being and being able to establish a relationship with a divine being. And kind of what I've written in Hidden Treasures in the Book of Job is, notice God designed birds and mammals to form relationships with a higher species, namely as human beings. And so of course he endowed them with the capability of receiving and expressing emotions, because that's an important part of their being able to develop a relationship with us. But it doesn't mean they're conscious like we're conscious. They have no awareness of God. They make no effort to try to discover God or to establish a relationship with him. They don't worship. But what we do see is that human beings indeed are aware of a being The other thing about consciousness, it's only we humans that express curiosity about things that have absolutely nothing to do with our physical survival. And so you don't see animals studying the planets or trying to figure out what's going on with the sun and the moon. They'll take advantage of the sun and the moon in order to get their food, but they don't really ponder the physics of the sun and the moon like we humans do. And we humans express curiosity on everything we come into contact with. And so we're curious about quasars that are 13 billion light years away. But again, it's tricky because people have a wide range of definitions on consciousness. And a couple of my colleagues are actually writing books. Will we ever build a conscious machine? And I love what an MIT artificial intelligence scientist said. We're 10 years away from building a conscious computer and always will be.
Dirk, do you have your hand up? And if you do, you're welcome to say something and unmute yourself. Did you just disappeared?
No, that wasn't the hand. I just lowered it.
Oh, okay.
Yeah.
You don't have a question.
No, I did. I just wanted to lower it as soon as I got called on.
Okay, go.
When I saw you in Austin, Dr. Ross, several months or years ago, you talked about how cultures that had horses thrived, cultures that didn't get out of the Stone Age. With respect to trees, have you ever seen examples where trees vanished from an area or were destroyed, and then the culture in that area vanished or died out? For example, Easter Island.
Yeah, well, I mentioned Arabia, and what's interesting about people who live in Saudi Arabia, every chance they get, they drive hundreds of miles to have some exposure to trees. There's only a few places on the Arabian Peninsula where you can actually walk through a forest, and they're jammed with people on their weekends, literally emptying out of the cities and going to those places. And yeah, there's been studies done there. Again, I'm saying there's been published work on children, but it convinces the same thing for adults. And just the fact that you see that behavior in Saudi Arabia. And hey, I think it's true of all of us, right? We do like to get away once in a while and go into some verdant forest and just enjoy being in that arena and seeing all the wildlife that's there. It's cooler to walk around in. It's easier to walk because you're walking on, pine needles instead of concrete. Do you have a follow-up?
No, I was just wondering if you had ever heard of any examples where a culture either chopped all their trees down or the trees just simply dwindled and died away.
Well, you mentioned Easter Island because they basically took down all the trees and then discovered that they didn't have enough trees to sustain their population. The rainfall dropped, they couldn't grow food like they used to. So, what I mentioned in my talk, just how trees are responsible for more than half the rainfall on planet Earth. I mean, if you take away the trees, there goes your rainfall. And that's, of course, going to have a huge impact on how much food you can raise.
Yeah.
Bill Dwyer, go ahead. You're muted, Bill.
Okay, my question relates to trees as well. In your book on climate change, you talk about reforestation as a way of combating climate change. What kind of area and time frame would be necessary to really have a significant effect on a local region?
Well, the one example I gave a couple of examples in weathering climate change, but the one that would have the biggest impact would be planting trees in what is now the Sahara Desert. And I mentioned in the book that it would be possible in less than 2 generations, maybe even just 1 generation, of shrinking the Sahara Desert by about a factor of 10. So making it 1/10 the size that it is right now.
That's very significant. How much water would be required to
When you
initiate?
rain. Pardon me?
How much
How do you
water is
initiate
required to
that?
initiate something like that?
Well, the Sahara Desert got as big as it is by people on the south side of the Sahara Desert stripping the land of vegetation and using that vegetation for cooking fuel and for heat at night. And when you take away all the vegetation, what that does is it cuts the rainfall down. So if you're taking out the trees on the south edge of the Sahara Desert, that's going to immediately drop the rainfall there by more than a factor of 2, which allows the desert to move south. And there was a time in the 1960s and early 1970s that the Sahara Desert was moving south at a rate of 6 miles per year. It's not moving that fast now, but it's still about a mile per year. And so what you do is you reverse that. Instead of stripping the south edge of the Sahara Desert of trees and shrubs, you plant trees and shrubs. And you begin by planting them fairly far apart, because if you plant them too close together, there won't be enough water for them to survive. So you spread them out, let those trees and shrubs begin to transpire water to the atmosphere, because those roots can go down deep into the bedrock, pull water out, they begin to transpire water, the rainfall goes up, which means you can now plant trees and shrubs of greater density and other plants as well. And basically what you do is you start pushing the Sahara Desert northwards. And you can do it not just 6 miles a year, you can probably do it at a rate of about 50 miles per year. And so in relatively short order, you can shrink the Sahara Desert by a significant fraction. Now, it would require the cooperation of all the peoples living on the south side of the Sahara Desert. And so what I proposed in the book is, why don't we use the fossil fuels in a way that would motivate them to work with the rest of us to replant the Sahara Desert? Basically saying, look, it's a lot easier just for you to take the kerosene we give you, use that kerosene for cooking and for heat, and work with us to replant the Sahara Desert. So I'm actually advocating, let's give them the kerosene for free on the condition that they commit their labor to replanting the Sahara Desert, because it's going to take a lot of people to replant the Sahara Desert. So they get the kerosene in return for labor to replant the Sahara Desert. And I think it's a win-win, because kerosene is a lot more convenient than pieces of shrubs and sticks that you pick up on the south edge of the forest. And they're going to benefit, because now they're going to be able to plant crops where before they couldn't plant crops at all. Now, where that's probably going to happen first is the Gobi Desert. The Gobi Desert's 4 times bigger than it was even just a few centuries ago, but it's caught the attention. I think we got somebody here who's joining us from Beijing.
Larry Price.
Yes. Well, Gary, you can go to the western suburbs of Beijing and you will see the Gobi Desert. The Gobi Desert has actually penetrated in the last few years the suburbs of Beijing. And so that's caught the attention of the Chinese government, saying, this isn't good. We need to push that desert back. And so that might be the first place we see action.
I think there's reports that they are doing that now. I've read reports that say they are doing that now. They are planting trees there.
Well, that could be done in several deserts, not just the Gobi and the Sahara. But that's where you get the most bang for the buck. You know, shrinking the Sahara Desert would be a huge economic boost to Africa.
You mentioned that Arabia doesn't have any trees. Is there any hope for getting trees in Arabia, or would they not even grow there?
Well, there are parts of Arabia that have trees, tiny parts. As I mentioned, the people of Saudi Arabia empty out of their cities on the weekends to spend a little bit of time there. Those little forest enclaves could be expanded. And when you expand them, you're going to increase the rainfall. For the very reasons I mentioned in the talk, because you're pulling water out of deep bedrock reservoirs.
There's some questions in the chat too.
Ah,
So John asked, I heard that neighborhoods that have many trees have fewer crimes than neighborhoods with no trees or few trees. Does that make sense?
I think it does because, my wife and I were friends with a lady who grew up in Manhattan, where there basically aren't any trees unless you get into Central Park. And her comment when she moved to Los Angeles is that she felt that she was in a national park. She was growing up in the what we would call Southeast LA, and none of us would really think of Southeast LA as a pleasant place to live. But from her perspective, the fact that there were trees there made it a park, because where she was raised in New York, there were no trees at all. So just concrete. So yeah, she said, I felt immediately a lifting of depression from me when our family moved to Los Angeles.
You want to hear?
I just wanted to mention, you were talking about pushing back the deserts. And just a couple of weeks ago, I read in the recently I read in the New York Times how in India, women who are being paid a nominal wage are planting mangrove trees to hold back the flooding from taking over. So it's fascinating to think of them doing double duty. It's a little bit like eating oatmeal. It helps you either way. And trees sound like that too. I guess it's fiber.
Yeah.
Huh.
Well, mangroves can grow in salt water. And so it's been well studied that planting mangroves along the seashore actually gives you greater protection from typhoons and hurricanes, and it stops the erosion of soil on the seashore. So yeah, a lot of places in the world are working to plant mangroves in the seashore areas. There's even talk about maybe that'd be a good idea to do in Florida.
There was another question in the chat from Dirk. I don't know if you want to ask it live or, well, I'll just read it. He says there's something in Japan called forest bathing, immersing yourselves in the forest, and it's supposed to have good psychological effects. Do you have any comments on that?
Yeah, I've been to Japan 5 times on speaking tours, and I've heard that very thing. And I think part of it is you're dealing with a very densely populated set of islands. And so, they have these nature preserves, but I've been to some of them, and yeah, you walk through this forest, but you're walking through the forest with tens of thousands of other people. It's not quite the same of having the forest all to yourself. I mean, I really love to go into forested places where I know there's more bears and more mountain lions than there are human beings. You really get a natural feel. I didn't have that sense in Japan. Well, I must say, I went into one of their forests and I was immediately surrounded by 200 Mac monkeys. And that was kind of fun to see all the monkeys running around. But you knew it was Japan because every one of those monkeys had an empty Coke can in its hand.
I will change the subject.
Looks like Lothar. Well, Lothar's got his hand up there, Kirby.
Okay, yeah, Lothar, go ahead. You unmute yourself, Lothar. You're still muted. There you,
Whenever I talk, it starts muting me again. Okay, here's the question. When you have more carbon dioxide in the atmosphere, the planet greens. Eventually you get more biomass. After you get more biomass, eventually it decays. And from that decay, you can generate natural gas again. You burn natural gas and you get more carbon dioxide. You can have a closed loop system of infinite energy. Is this hypothesis accurate, or is there some flaw in that logic?
Well, what I wrote about in weathering climate change is that there's a better way to manage our forests to keep the greenhouse gases from rising. And that is, don't let the big old trees die and decay. You know, if a big old tree falls down the forest and then begins to decay, it's going to be releasing all of the carbon that's stored in that tree back to the atmosphere. We'd be better off harvesting that big old tree before it dies and decays. Because when you harvest it, you can convert that wood into homes and furniture, and you can, you know, stain the furniture and the home in such a way that the wood doesn't decay. And so now you're sequestering the carbon. It's true that forests sequester carbon, but if you let the trees decay, then all that carbon gets released back to the atmosphere. The other thing I was making mention of, it's a lot of studies demonstrate that young and middle-aged trees grow a lot faster than old trees. These really old trees are growing very slowly. And so you want to make sure that your forest is predominantly made up of young and middle-aged trees that are growing fast. And hey, that's where you're going to make the most money in terms of lumbering. The faster the trees grow, the more money you're going to make in your lumbering enterprise, the more greenhouse gases you're pulling out of the atmosphere. However, you want to ensure that you leave at least some of the big old trees in the forest. Because, for example, the redwoods in California, they play a crucial role in capturing incoming fog off the ocean. And that's a lot of the water supply for those forested regions in Northern California. And if you cut down all the redwoods, then suddenly that fog capture is gone. And also there's certain species of animals that are critically dependent on big old trees. However, you do want to harvest the trees when they're at their point of dying, because when they die, they're no longer going to capture fog. They're not going to be a habitat for those animals. And so proper forest management. And the thing you don't want to do is clear cutting. And so the best way is to actually go through the forest and selectively mark the trees you want to harvest so that you always have a forest. You actually, what the studies have shown, lumbering companies, if you're looking on a 10-year basis, make more money through selective harvesting and replanting than they do through clear cutting.
Mhm.
Well, thank you. But perhaps I should have framed that question a little bit differently, because in Japan and some other countries, there's fermentation processes where they take that biomass and convert that to fuel. And they also, like farmers in Iowa, take the pig poop and have natural gas, make that out of that. So if you consider biomass as all plants and all animal waste as one bucket, you can make quite a bit of fuel from that. And I wasn't really talking about.
That's a good idea, Lothar, because that waste is going to decay and make carbon dioxide anyway. Why not convert that into fuel? And there's one study that got published recently where they came up with an economical way to pull carbon dioxide directly out of the atmosphere and convert it into jet fuel. So they basically use an array of solar panels and then a little factory that takes the electricity, from the solar panels, carbon dioxide from the atmosphere, and the product that comes out the other end is jet fuel. And they're basically claiming that if they can convert 10,000 square kilometers of the Sahara Desert into solar panels, they can produce enough jet fuel to cover the entire world's aviation industry. And so that would be a net zero. You wouldn't be using any fossil fuels from the ground. You're basically pulling it from the atmosphere and putting it back into the atmosphere. Yeah, I wrote a blog on that, so you can search today's new reason to believe and find that article. And of course, if you want to cover more than 10,000 square kilometers, you could conceivably take care of the trains and the trucks that run all over our planet as well.
Ray Uzel comments that Israel has been planting trees extensively since about 1900. They have reclaimed part of the Negev desert. Would you comment on that?
Yes, well, I visited Israel in 1980, and that was just 13 years after the 67 war. And already they had forests over the Judean highlands. And I saw photos of that same area previous to 1967. It was bare rock. Nothing was growing there at all. And now they got fruit trees. They've got coniferous forests growing there. So yes, the Israelis have shown us that you can actually replant a rather dry area quickly and make it productive.
Any other comments or questions? I would like to change the subject briefly, and that is we've seen in the newspapers the last couple of days the pictures from the Event Horizon Telescope, and I think you've actually written a blog on or a tweet on this anyway, of the black hole at the center of the Milky Way, and as well as the black hole at the center of Messier, what is it, 187? And would you comment on those? I thought those pictures were weird. They didn't really tell me very much.
Well, I did write a blog back in 2019 on the black hole event horizon at the image in M87. And that's the easiest one to image because M87's got a supermassive black hole that weighs in at 6.5 billion solar masses. The one in the center of the Milky Way galaxy is only 4 million solar masses, so it's a lot smaller.
Only.
Well, it's the tiniest supermassive black hole for a galaxy of our size by about a factor of 40 times. I mean, if you go to the Andromeda galaxy, which has the same mass as our Milky Way galaxy, its supermassive black hole comes in at 140 million times the mass of our sun. And they're using what's called the Event Horizon Telescope. And that's anywhere from 10 to 13 radio telescopes that they link together as an interferometer. And these telescopes are all over the world. And so, a really powerful optical telescope will have a mirror diameter of maybe 10 meters. They're actually building one now that's 30 meters. Well, this particular array of radio telescopes has the equivalent resolving power of a telescope that's 6,000 miles in diameter. And so it's by far the highest resolution telescope that astronomers have. And it's the only telescope that's got the resolving power to actually detect the event horizon of a black hole. And the event horizon is that distance from a black hole where nothing can escape the pull of its gravity, not even light. And so when you see these images, they kind of look like donuts. You see a black hole in the center, and you see some bright light around that circular hole. And what's happening there is that the black hole's gravity is pulling matter towards it. Stars, comets, asteroids, gas, and dust. And as that matter moves towards the event horizon, you get such strong gravitational interaction with that matter that it's converting anywhere from 10 to 40% of the matter into energy. It's the equation E equals mc squared. Now, to give you a point of comparison, the nuclear furnace inside of our sun is converting matter into energy with 0.07% efficiency. And that allows the sun to be as bright and as hot as it is for 9 billion years. But what's happening outside these black holes is that the matter that's being sucked towards the event horizon is being converted into energy with 10 to 40% efficiency. So that explains that ring of light you see around the black hole. But the objective of the Event Horizon Telescope team is to accurately as possible measure the diameter of the event horizon. So they're wanting to measure the size of that black region where there's no light. And because that's going to enable them to understand certain theories of gravity and maybe even give them some significant insights into what's called quantum gravity physics. There's only two ways we can explore the quantum gravity era of the history of the universe, and that's through examining the event horizons of black holes and looking at the images of distant blazars and quasars. And I've written about that in the 4th edition of The Crater and the Cosmos, how atheists often will appeal to the quantum gravity era. And by the way, calling it an era is a bit of a misnomer. We're referring to the first 10 millionth of a trillionth of a trillionth of a trillionth of a second of the existence of the universe. So it's an extremely tiny, tiny portion of a second. But it's that early history of the universe where quantum mechanics competes with gravity for governing the dynamics of the universe. And so this is where atheists have been speculating. Well, maybe there's quantum space-time fluctuations that are so enormous in the quantum gravity era that the space-time theorems fail. And therefore, maybe space and time are not created. Maybe there isn't a God beyond space and time that creates space and time. However, by studying these distant quasar images and measuring how blurry the images are, and by studying the characteristics of the event horizon of these black holes, we can actually put a limit on those quantum space-time fluctuations. And as I wrote in the 4th edition of The Crater and the Cosmos, already the images of distant quasars and blazars have put a severe limit on the size of those quantum space-time fluctuations, indicating in all likelihood the space-time theorems hold all the way back to the very beginning of the universe. And therefore, you really do need a God beyond space and time creating everything. So you want to know the value of your taxpayer dollars for the event horizon thing. And by the way, it's a cheap experiment. You know, somebody put on my Facebook page, how many billions of dollars did this cost? I replied by saying, the only cost is the salaries of the astronomers that are doing the research and the money they have to pay for computer time. The telescopes have been operational for literally more than 10 years each. They're just taking existing telescopes and linking them together to make an interferometer.
Anyone else?
I just wanted to say a quick thank you for the latest podcast that you're doing, Stars, Cells, and God. I've really enjoyed those. So, and then a different thing, we were talking about black holes. Somebody said, what about white holes? Are those for real, or somebody found it on Wikipedia as a theoretical, but I wasn't sure if those,
Right.
what the thoughts are.
Well, it was Stephen Hawking, when he was alive, who determined that white holes are actually possible. Is that you have a black hole and it's sucking matter into itself. And even if it's not sucking any matter into itself, the gravity is so strong that the black hole keeps getting smaller, smaller, and smaller. And so with Stephen Hawking, he said, if you wait long enough, these black holes will actually shrink down to the size of a fundamental particle. They'll shrink down to the size of a proton or an electron. And when that happens, then the dynamics initiated by quantum mechanics could actually become stronger than the gravity. And therefore, this black hole could actually become a white hole, where once it shrinks down to the size of a quantum particle, quantum mechanics could actually supersede the force of gravity, and therefore everything that was trapped inside the black hole would radiate out in a spectacular explosion. And that's what they call a white hole. It's where a black hole evaporates everything that's been inside of it.
Okay.
Now, Stephen Hawking calculated how long it would take for even the tiniest black hole to become a white hole. The more massive the black hole, the longer it takes to shrink down to that size. The smallest conceivable black hole would be a black hole about 3 times the mass of our star, the sun. And that would take 10 to the 66 years before it would become a white hole. So we're going to have to wait a while before there's going to be any white holes.
Okay, thank you.
Anyone else?
Has Lothar got a question?
Go ahead.
Lothar, do you still have a question, or is that just your hand from last time?
Hand from last time.
Okay.
Yeah, there's a thing where you can take your hand down.
There.
There you go.
I got it. There was also something in the chat where somebody mentioned that we see in the New Testament, the land of Israel seemed to be pretty well forested, grass on the hill where they sat down to feed the 5,000, et cetera. And I think I've heard something similar, that Israel used to be much better forested than it is today. And I've heard it claimed that it was because the inhabitants didn't follow God's laws on Jubilee and other things and letting their land rest, that and they deforested the place too much and just wiped things out. Do you have any comments on that, Hugh?
Yes. It tells us in Leviticus that you need to let your agricultural land have a Sabbath every 7 years. You work it for 6 years, the 7th year, you don't plant, you just let it sit. And there's actually a good scientific reason why you want to give the agricultural land a Sabbath rest. It starves the nematodes. So when you don't plant anything, the nematodes don't have anything to eat. And so it brings the nematode population down. And so it doesn't eliminate the nematodes, but it dramatically reduces the nematode population. And that's the biggest factor in terms of your productivity. If you don't keep the nematodes under control, they wind up eating all of your harvest. And you say, well, how come people don't do that today? Well, we use chemicals to take care of the nematodes. And so now people are able to plant their agricultural land every year without worrying about the nematodes. All you got to worry about now is the chemicals that's on your food. But yes, archaeologists tell us that when Jesus was roaming around in Israel, probably the population of Israel at that time was a little more than 5 million people. Now that's without industrial, civilization. And so that was probably the peak population Israel had in ancient times. But also indicates that, Jesus, as he wandered around and preached throughout Israel, actually had contact with a significant population. The Roman Empire as a whole at that time had a little less than 200 million people. but there were 5 million in the land of Israel alone. And yeah, it's because the land was well managed. And it was when the Jews were the diaspora in 70 AD, that's when the land began to degrade. And by the time you get to the Middle Ages, it's basically barren.
Well, I don't see any more questions.
I got a
I hate to
question.
let Hugh go this easy. It hasn't seemed like we haven't really stressed him too much.
I got a question.
Dirk has a question.
Go ahead.
Actually, two real quick questions. Have there been any updates to Lights in the Sky and Little Green Men since 2002? And is that your only book on demonology and the occult and with its relationship to UFOs?
Yes, although you do see something about demonology and the occult in the book, Always Be Ready. I got a little bit in there where I talk about the time I was in the Soviet Union when the Soviet government was sponsoring departments of occult physics at their major universities. And so you'll find a little bit there in a chapter, but we are planning a second edition for Lights in the Sky and Little Green Men. And people ask me, well, are you going to be deleting anything from the book? There's nothing in the book that needs to be corrected, but there's a lot more that's been released by the governments of the world on UFOs. So we'll update that, but we're not changing our conclusions.
That was one of your earliest books, was it not?
It came out in 2002.
Oh, really?
Yeah.
I thought you had one way back in the 80s.
Well, in the 80s, I had messages on the UFOs and demons. I mean, as I mentioned in the book, I've been studying that, not willingly, but I've been studying UFOs since I was 16. And that's because I always got fingered because I was an amateur astronomer before becoming a professional astronomer. So every institution I went to, they said, well, you know the night sky. You're going to be the guy that's got to process all the reports we get.
And they stuck you right next to the UFO tent or table.
Yeah, that happened when I was 16 when we had a astronomy club exhibit at the Pacific National Exhibition. They put us right next to the Flying Saucer Club.
You mentioned quantum mechanics a little while ago. I'm curious if this is a question for my brother, but he had a question about consciousness and quantum mechanics and whether quantum mechanics points to a celestial consciousness, i.e. God, and whether someone could use quantum mechanics as an argument for deism.
Yes, probably the best example of that is a couple of books put out by the British mathematical physicist Roger Penrose. And he was trying to explore, is it possible to explain human consciousness with physics and chemistry without appealing to the supernatural? And in his books, he made the point, the best possibility are the microtubules inside the neurons of the human brain. But if you read his books, he basically made the points. It's possible those microtubules might be able to explain the storage of information in the brain, the equivalent of what your hard drive in your computer does. And he says it might even be able to explain some of the software that evidently operates in the human brain. But he says for sure one thing it cannot explain is the programmer. The fact that there's something within the human mind that's able to control the physical interface. And so he came up with the idea that the human brain is a physical interface for the human mind. And the human mind is not a physical entity. And so today, Roger Penrose identifies himself as a theist, not as a Christian, but at least as a theist. And so he's been exploring these ideas. And what I find fun is a book that he and Hawking wrote based on a semester-long course they taught where they debated God and Physics and Eternity, where each of them alternated for a lecture in the class. And you got Hawking defending deism, and you got Penrose defending theism. And the audience is filled with professors of physics and philosophy, theology, as well as all the students that were required to take the class. But the book that they publish is a very entertaining book. And consciousness is one of the things they talk about. But yeah, I agree with Penrose. You're not going to explain human consciousness with physical matter. We humans are dualistic. There's a spiritual component inside every human being. And Gary Habermas in particular has spent the last decade doing research, making the point that there are experiments you can perform that establish that we human beings indeed are dualistic. You know, out-of-body experiences, near-death experiences. And I was talking with him about the fact that 35% of the time when a Christian dies, the surviving Christian relatives get a vision, basically reassuring them, don't worry, I'm in a good place. Mm-hmm. And what Gary was sharing with me is that the visions are remarkably consistent, lasting about 5 or 6 seconds. They happen when the individual is fully awake, not when they're dreaming or sleeping, when they're completely awake. And it's always showing the dead Christian friend that recently passed away in a beautiful place, reassuring them, don't worry about me, I'm with the Lord. And he says that happens most frequently when the surviving Christians have doubts about whether or not the individual really is a follower of Jesus Christ. Mm-hmm. And we talked about this, and I said, well, it's interesting you share this, Gary, because, you know, my older boy was in an incident where they were jumped by 3 very violent men, and his friend got killed, and my son was almost killed. Took 60 stitches to patch up all the stab wounds he had in his stomach and lungs. But his friend wound up dying as a result. And, you know, it was a couple of days in the hospital where my wife and I were worried about whether his son was going to survive or not. And he finally got to a point where his blood pressure came up, and we realized, okay, I think he's going to make it. Then they took everything out of his face. He was actually able to talk to us. And he thought for sure his friend had survived. We had to tell him he didn't. And I remember how depressed he was for a day. The next day, I was with my son, and I saw my son's eyes bug way wide. And he said, Dad, do you believe in visions? I said, son, what did you see? He said, I saw my friend Ryan in a beautiful forest waving to me and telling me not to worry. Mm-hmm. And my son was worried because this particular young man, he was studying to become a pastor, but he said, before I become a pastor, I want to find out what life is really like. And so he was hitting a lot of bars and doing things that made my son worry about his Christianity. Anyway, 3 months later, I talked to the father of that young man. And the father is a pastor of a mega church. And he said, tell me, what time did your son have that vision? And what was in the vision? And he told me he had the identical vision at the identical time. But Gary Habermas tells me stories like that are really common. The database is enormous. And if you want to go to our old website, we actually have a 2-hour interview. Fuzz and I interviewed Michael Sedone. He's a medical doctor, and he's written, in our opinion, the most critical books on near-death experiences. He was a surgeon, and what he would do is he would put written messages on the top of girders in the operating room. And so when his patients would say they had an out-of-body experience and were looking down on their body, he would say, well, how high up did you float? And they would tell him and said, well, did you see a message on the top of the girder? They said, yes. Tell me what the message was. And he's told us that frequently these people would give them the identical message.
Hmm.
So he says that's what persuaded them. These experiences are real.
Hmm.
They really did leave their bodies. The spirit within them left their bodies. And they're actually able to read the message on top of the girder. And he told me he did that dozens of times, and that the people always got the correct message.
Hugh, you might know that Walter Bradley has been looking into this too, and
Oh yeah.
he gave a talk. He gave a talk a few years ago at ASA that my wife caught,
ETS.
or ETS. My wife went to. I missed it.
What was the name of that doctor?
Michael Sabom, SCBOM. You can look for him on the web. He's got a couple of books that he's written. And we're going to try to get the interview that Fuzz and I did transferred over to our new website. There's several old interviews we've got there. I mean, we interviewed some origin of life researchers I'd love to pull over, including one with Robert Shapiro. But yeah, the one with Michael Sabone would be good to get over to. So it's something we're working on. But yeah, I had a talk with Walter Bradley. I got to have dinner with him when I was in Austin a few weeks ago. And he told me about the latest work he's doing on the near-death experiences.
Kay, did you have a question?
Yes, I did. Could you comment on how you, as a astrophysicist, as you see the development of our planet over billions of years, how do you line that up with scripture talking about the creation in 7 days?
Yeah, well,
I know it's a big question. Maybe you would just have a book I could read on it or something.
Yeah, if you want to read a book, Navigating Genesis, or if you really want to go into it in detail, my book, A Matter of Days. It's at the printer right now, so it'll be available shortly.
It's by you, you said?
Yeah, I wrote the two books.
Okay, A Matter of Days.
A Matter of Days and Navigating Genesis. And basically, I'm making the point that the word for day in Genesis 1, yom, has 4 lexical distinct definitions. Pick up any lexicon, you'll see it can either mean part of the daylight hours, all the daylight hours, a 24-hour period, or a long period of time. And in Genesis 1 and 2, it uses 3 of those definitions. So you don't have to be a Hebrew scholar to realize this word has multiple literal definitions. On creation day 1, it uses the word day for the daylight hours. On creation day 4, it uses the word day for the 24-hour period. But in Genesis 2:4, it uses the word day to refer to the entirety of creation history. And, I didn't really pick up a Bible till I was 17 years of age. And this is long before I ever went into a church. But when I looked at the book, I realized there is an evening and a morning for the first 6 creation days. And I said, I don't know what those words evening and morning mean in the original language, but at a minimum, I know they're saying that each day had a start time and each day had an end time. But when you get to creation day 7, there's no evening morning phrase. So the day had a start time, but there's no indication of an end time. And that's consistent with what you see in Psalm 95 in Hebrews 4, where it tells us that we're still in God's 7th day. And the 7th day will not end until the full number of humans that God intends to redeem have been redeemed. And so we're still in God's 7th day. And when I read that as a 17-year-old, I said, this answers the fossil record enigma. It explains why we see the appearance, a very rapid appearance of new phyla, new classes, and new orders before human beings, but we don't see any of that after human beings. For 6 days, God creates. On the 7th day, he stops creating. Also explains why so many biologists say we see no evidence in our research for the supernatural handiwork of God. Well, if they're looking in the human era, they won't. All they're going to see is a natural process because God has ceased from his work of creating. But if you look in the pre-human era, you see evidence for it everywhere. And I think the most obvious examples would be the origin of life, the Avalon explosions, and the Cambrian explosion. There's a book written by James Valentine. He himself is an atheist paleontologist, but he said, our model's in trouble because the phyla diversify before the species. All naturalistic models predict the opposite, that the diversification of species leads to the diversification of genera, which leads to the diversification of families and orders and classes, and phyla last of all. But when you look at the Avalon and Cambrian explosions, the diversification of phyla occurs first. The diversification of species occurs last.
Thank you. When is that book supposed to come out? You said it hasn't come out yet?
Oh, no, it's been out for quite a few years.
Oh,
but we're
okay, I'm sorry.
reprinting it. 3 of my books are at the printer now. 2 of them are being reprinted, and 1 of them is designed to the core, and they're giving priority to design to the core. If you're not aware, getting anything printed these days is a challenge.
Yeah.
We used to be able to get things printed in a week. It now takes 3 to 4 months to get something printed.
Okay, I have both of those books, and you're welcome to borrow them if you'd like.
I'd love to. Thank
Okay.
Yeah, and all of my books are available as ebooks. Yeah, the paper editions are being held up.
Well, I think we have taken enough of your time now, Hugh, and I really appreciate your spending as much time with us as you have. I wonder if you would close this meeting with a word of prayer.
Yeah, I'd be happy to do that. Father in heaven, we thank you for the privilege of living in the 21st century when there's so many people to bring to faith in Christ, people everywhere, and the technology you've given us to reach people, not just in our immediate area, but literally around the world. So Father, we're grateful for that privilege. We're also grateful that we're living at a time when we're seeing more evidence for your handiwork than ever before in human history. And Father, I pray for all of us in this meeting that you give us, through your Holy Spirit, the sensitivity to know when you're providing an opportunity to share with the people who don't yet know you as Lord and Savior good reasons for the hope and faith that we have in Jesus Christ. And give us a capacity by the power of your Holy Spirit to share those good reasons with gentleness, with boldness, and with respect and compassion and love. In Jesus' name, amen.
Amen. Thank you again.
Thank you so much, Hugh.
Thank you.
Very welcome. Very welcome.
Thank you, Hugh.